Okay, so next I would like to talk about what a reaction mechanism is. So when we write a balanced chemical equation, it's actually just the overall net reaction for the reactants that react with one another to form the products, but it does not necessarily mean that it happens in one step, which may allude to that when we're just looking at a balanced chemical reaction. So the reaction mechanism, it tells us more details about the steps that's taken in a chemical reaction. Does this happen in one step? Does it happen in multiple steps? So here's an example of ozone that's decomposed in two steps. So here are the two steps that happen, right? The first step, it decomposes into oxygen gas and oxygen, and then that oxygen that's formed reacts with the ozone to form oxygen gas. So these two steps in the reaction mechanism are what's called elementary reactions. And the elementary reactions should sum together to give the overall net reaction or overall balanced chemical reaction. So when we talk about the decomposition of ozone, this is the overall balanced chemical equation. Now notice that we have oxygen that forms here in step one, that it appears, right? So it's a product in step one, it's produced, and then it is a reactant or consumed in step two. So these are called intermediates. Intermediates are produced in one step and then consumed in the next step. So how would you draw this reaction mechanism on an energy diagram? So I want you to actually pause this video and do just that. I want you to draw the reaction mechanism on an energy diagram. So we know what reactants and products we have, right? But this is occurring in two steps. So we're going to talk about this in discussion. This is occurring in two steps. We've got an intermediate that's formed. So I want you to think about and really make an attempt of mapping this onto an energy diagram. So here's another example where we have nitrogen dioxide reacting with carbon monoxide to form nitrogen monoxide and carbon dioxide. So these two reactants actually come together, right? They actually come together in forming this transition state. This is not always the case, right? Like what we saw in our previous example, but here is a case where the two reactants do interact with one another to form a transition state and then form the products from the transition state. So when we have a reaction mechanism with multiple steps, there's usually one step that happens really slow. And this slowest step is what's called the rate limiting step or the rate determining step, right? Because it is the step that can determine the overall rate of reaction. So here is an analogy or just like a non-chemical example to help us conceptualize what we mean by rate limiting step. So this is a cattle chute. And the rate at which they can move the cattle from one pen to the other is limited by how fast one cattle moves through the chute. So essentially, it's the slowest step, and we can't move to the next step until that slow or rate limiting step takes place.